Hello and welcome back to the Green Workbench. Today we're going to talk about how my experiments in heating the greenhouse over the winter. I've now had the greenhouse through one full winter. Spring is here, warm weather is here. So what are the things that I tried, I used this year kind of as an experiment. So I want to talk about the things that I did. So we're going to start here on the outside and then we'll move in. Please excuse the goat noises. She got in trouble because she was allowing other kids to feed from her while not allowing her own children to feed from her. So she's been sequestered with her kids. Okay, so first here we have a solar heater. So you can find a lot of those online on YouTube instructions, but basically you've got a box, an insulated box with a glass front. Behind that glass is a piece of black metal, and behind the metal is an air pocket. The cold air goes through one end, moves through the channels behind that black steel as it heats up, and then there's a pipe at the other end attached to a solar fan that blows that hot air into the greenhouse. So on a cold, sunny day during the winter, it works really well. It would push air that's over 100 degrees into the greenhouse, even when it was below freezing outside. Of course, it only works when there's sun. And then above it, you'll see I have one solar panel and a windmill. My greenhouse does have power wired to it, but in order to try to reduce the amount of electrical power I'm using, I was also experimenting with solar and wind. And those are connected to a battery and an inverter inside to run some of the other programs. Okay, what else on the outside? Obviously, we have a large surface for the sun to hit the plastic. Actually, because of the angle of the sun and how much sunlight I got in the middle of winter, my ceiling is much higher than I would have normally made it, which is actually hurtful at night because heat rises. So heat was up at the top of the greenhouse instead of down where the plants are. So I'll tell you how I worked around that. Third, my greenhouse is half buried underground. So we're going to move down here. And I also surrounded it with straw. So I'll talk a little bit more about that later because we're going to discuss what I plan to implement for next year as well. So now let's move inside. Okay, so now we're inside. Let's talk about, first of all, thermal mass. So I've got this garbage can's full of water. This garbage can's full of water. This is my rain catchment, which is full of water. And they also have other 5-gallon buckets full of water, so providing thermal mass. One way I use to heat that thermal mass, which allows a little bit more heat to leach out during the night, is aquarium heaters. So you can see over here, I've got an aquarium heater that's in the larger garbage can. Keep that at about 85 to 90 degrees Fahrenheit. That's warm water. And then throughout the night, that heat radiates off of that thermal mass into the greenhouse. The smaller garbage can down here has a smaller aquarium heater in it. They don't use a ton of power, so those are always plugged in. They're unplugged now because it's warm enough. And then you'll also see over there my solar controller and my wind controller all going to a battery. So that battery can run those aquarium heaters at night. Now, I did find that battery is not, one battery is not enough. It's a lithium phosphate battery. So I plan on getting another solar panel and a second battery that will increase my capacity at night. And then you may have seen over here, I have an inverter. The reason it's here is because on hot days, I have it connected to a fan in the doorway. Right now it's connected to this aquarium heater, but not turned on because I don't need it right now. So that thermal mass keeps a lot of the heat in, but again, because of the high ceiling, it can be problematic. So let's look at the next item. Okay, you'll see right in front of me, I've got a heat lamp. We'll talk about that and why it's hanging so low in a minute. But basically on the back wall, so this is the wall that gets the sun, I have this foam that's painted black, and that heats up in the sun really well. So right now, hey Google, what's the temperature outside? Okay, so today it's 59 degrees outside. And that the back, that is, I don't know if you can see that, currently 124. The surface of that, 135 there. So the surface of that foam, colored black, is 135. And then you can also see that the cinder block walls I have covered in foam all the way around to include the door. There's the pipe with the hot air from the solar heater coming in. So even the door is covered in foam. Okay, so now electric. That device right there is a temperature switch. So when it hits below a certain temperature, it switches on. That's connected to house power. And then under here, see if you can see it. That is just a cheap food dehydrator down underneath. So I had plants planted in these boxes during the winter. So when the temperature got below, set it at 50, 45, whatever you want to set it at, that would turn on the dehydrator, which blows air that's about 125 to 150 degrees, keeping the soil warm and then just blowing hot air down low in the greenhouse. So that would turn on automatically. And then the big backup that uses the most power was this temperature controlled greenhouse heater. So it connects to Wi-Fi and you set it so you can monitor it in your phone, but you set it when to turn on. So when it reaches a certain temperature, it will turn on. And then when it heats it back up so many degrees, it will flip off again. So when it got really cold, it was on quite a bit, which raised our bills. Unfortunately, my inverter and battery situation so far isn't large enough to handle that kind of wattage from this heater. So my goal is for this to be the emergency backup and to not turn on very often. And as the winter went on, we got a pretty good balance. So this would only turn on maybe a couple times during the night with all the other lower powered options. Okay, I want to show you what I did about the high ceiling, how I solved that problem at night. So let's see if we, so this piece right here, you can see is laying on that 2x4 across. So essentially what I did is I used foam board to create a false ceiling, insulated ceiling. And I have pieces that go all the way across the greenhouse. They keep the cold air up. They trap the hot air down, reflect it back. And then if you remember this heat lamp, it falls below that foam layer, that low ceiling. So on a night that I know is going to be really cold, I could turn on this heat lamp, which it uses less power than the heater, put the faux ceiling up. The heat would project, this lamp would project the heat down, and then it would bounce and reflect off of the insulated ceiling and keep the heat lower. And that actually made a huge difference once I started using this insulation for the false ceiling. And I can show graphs of that because I'm maintaining a history of the temperatures. But that made a huge difference, just bringing that ceiling down low at night. And then in the morning, I would take them off to let the sun in and let the entire space heat up. Okay, if you're wondering why I have these reflective surfaces below my black surface, and even the mirror there, that is because of the low angle of the sun in the winter and the shadows I get. When the sun comes in really low, it hits around at about that level and reflects back into the greenhouse. So that's why I have so much reflection going on in here. That really helped out in the winter as well. All right, let me show you kind of the final emergency solution for the days, the nights when it was getting below zero, which luckily last winter we didn't have a ton of, but it does happen here. Usually it will last for a few days at a time. So let me show you that. Okay, here is my solution for that. So this is an alcohol-based stove. This is carbon felt so that it burns pretty much forever. Fill it with a clean alcohol. Let it wick up the carbon. It burns. This acts as the, I can't remember the name, not filament. But anyway, it heats up, reflects off of this steel background, and it lasts quite a long time. So for the coldest part of the night, the stove is going and reflecting that heat back, and with the false ceiling, keeping the heat down, and this heat-driven fan on top, we're blowing hot air, and we kept it above freezing, even if it was zero outside. So I did have to use this a couple times. And then there was one other thing that I tried, and I'll show you that. All right, so I tried this little stove, wood stove. It's supposed to be smokeless, but it's not at all. And throw some hardwood in there, set it to burn. Now, it would raise the temperature in here very quickly. It would go from in the 20s up to the mid 40s or 50s within a few, probably 10, 15 minutes. But the greenhouse filled with smoke, which wasn't cool. And once the wood burns out, it just gets cold. Like the heat doesn't really stick around. And I couldn't use the faux ceiling because there was so much smoke. I needed the smoke to go up. So wood burning is a kind of last ditch effort. If it's getting too cold, nothing else is working. But it was not a great solution, and it was one that would require you to keep feeding the fire all night. An alternative would be to build a chimney for this, and so that I could push the smoke outside, and then I could use the lower ceiling. But I don't have a ton of room to build a wood-burning stove in here. And if I were going to do that, I would just buy one that has a chimney already attached. So those are the heating efforts that I used on the inside. So let me show you what I'm going to plan for next year. Okay, so I've ordered a chip drop, which if you don't have it in your area, basically a tree company, instead of having to take their wood chips to the dump, you sign up, they'll come and drop it off at your house. Their mama goats still going at it. So essentially I'm going to create a pile of chips and compost all the way around the greenhouse to create that compost heat during the winter. And then I'll run pipe through the middle of that compost with a fan blowing air from the pipe into the greenhouse. So that compost builds up heat, which will heat up the air in the conduit or the pipe, and then I'll have a fan that can be run off the battery, blowing that heated air. And it won't be super hot air, but it will be hotter than outside. It will be heated, and with the faux ceiling, that should keep some extra heat inside. So basically, I'll just create a fence around here, bring it out probably 3 feet all the way around the side and the back of the greenhouse. And so that will be my passive heat generator for the night. Because the biggest issue with creating heat in a greenhouse is at night. A greenhouse is solar powered, so once the sun goes down, you lose your source of heat unless you're using all the alternative methods that I talked about. So there were a couple others that I tried. I tried making a sand heater with a heating element inside sand. That didn't work too well. Let me show you what happened there. I'm sure I probably did it wrong, but so this is from a stove element that was in the sand, and it essentially burned that stove element until it broke apart, which wasn't awesome, a little dangerous. So I quit that and stuck with these methods I've talked about. So that was my first year of experimenting with heating my greenhouse. Let me know if you have any other suggestions that don't require a ton of electricity. But with the kind of levels of heating that I had, my highest electricity draw was the thing that turned on last. So I went from low electricity to high, and as long as it didn't get too cold at night, I wasn't using a ton of electricity. And if it was going to be that cold, I could use that stove. And even though the alcohol costs money, at least that fan heater wouldn't be running all night. So that's how I worked on heating my greenhouse. And that's what the goat thinks about it. So let me know if you have any questions or comments down in the comment section, and I'll catch you next time on the Green Workbench.